preferably earlier. And we were originally trying to get the code done for end of today. So I think we made some decent progress with the code. I think we're not miles away from having, so we have the basic implementation for those who don't know. There's some issues with multiple miners, but I think at a minimum we can probably get most of the crypto stuff working with a single miner set up, as something. We've got a day to look at that. But I think I've spoke to Costin about the code, but for the other guys, we had a few tasks in the GitHub page. I don't know if you guys saw the issues page around things like the report preparation, presentation, also some research stuff. So basically, we're trying to understand where we're up to with the presentation, and what work needs to be done so that it's ready on, well, Tuesday night, really.
I've been working on code with you, Alex, so I haven't done almost anything doing for the presentation. I've done just a tiny bit of research on why we're using RSA, and that's about it. I've been trying to focus on getting the code working. So
yeah, I know, yeah.
Just telling for the other guys.
I think I will do a good job of PPT, speeches, and reports. And I think I need someone who is good at spoken English.
Okay. Do we know what we want in the presentation? We've obviously
to
got
demonstrate
some...
and answer the PPT and the report.
Yeah, I mean, I don't mind speaking in the presentation, but I'm pretty sure I don't have time to do the presentation and what I'm currently doing.
Yeah, so
I've been doing like 8-10 hour days just for the background for how much I've been doing for the last kind of 3 days trying to get this thing to work. So basically running out of daylight. But yeah, I think I don't mind, actually talking in the presentation, but I guess, do we know what we want in the presentation? We've obviously got some rough PDFs that we have at the moment.
Same with me. I don't mind speaking, but I really like now we don't have time. Me and I really don't have time to work on a presentation. Basically, for the presentation, I think we want to specify what the background research and why we changed some things from the original plan, what was the original plan, and what got implemented. That's basically it for a presentation, I think. If anybody else has any other idea, maybe get some screenshots of the actual app running once we get to that point.
Okay, let's I'll show my screen. Let's have a look at if there's any information on the requirements of the presentation.
Yeah, so design decisions, if you go a bit up, Alex.
Yeah, I'll go up in a second, yeah. So it's not the demo, so it's this, right? So the report's important. 10%, okay. It's not as bad as I thought. No. I'll go back to the design decisions thing, because there's stuff that I was obviously in flight that I'm hoping we can get fixed, but the stuff that we've already decided on. So the RSA one is a prime example of something that's been decided on, so we can talk about that.
Also, why we chose Python.
Why we've chosen Python. The other thing, it's it may seem a bit, like excessive, but either in the presentation or the report, we can actually talk about all this, how we used Git, how we, check stuff in, how we, formatted the code, run tests, because this is 3 points basically, and it's just part of the process.
Yeah, definitely. That's.
Let's look at I'll go about design decisions in a second.
Yeah.
So we also talked about the networking stuff. So we'll probably maybe go through the Costin's slides after this and say what we've got working and what we don't, and reasons for that. That's the algorithm. Right, so things we've decided. Then if someone wants to make a note while going through this, just in terms of things that we maybe need to have in the slides.
Yep.
We've decided to use Python. So the main reason for that, I think, was based on the actual library support. That when we looked at Mininet, we did all that research, and the examples in the documentation were all in Python. The thing's natively written in Python. We had a majority vote on use of Python, and I think the majority vote was that it was going to be easy to implement. So that's basically why we went with that. We also used Python for the actual code, so the stuff that runs in the sub-processes, and that was to basically have a unified development, environment, so that we were using the same tech stack for the actual code to launch Mininet and the code to run inside it. That's probably enough for that. We looked at LGAML versus RSA, and we've got some more notes somewhere, I think. So we probably need someone here other than me or Costin to go through the, I think Zach had some notes. I think this might be copy and pasted straight off the internet. It's just, I wouldn't copy any of this. It's gonna have to be paraphrased. But I think the gist of it was that the library support for the library that we used. So we used, if you've not seen the code, we used this thing. So the original PyCrypto thing is probably also worth mentioning, which is recommended in the specification. Is a dead project. It's not maintained and it doesn't work. So we then went with PyCrypto Dome, which is a fork of that, and it's basically a continuation of that, as I say here, that works. So we use that for the crypto library, and in terms of the actual asymmetric cryptography implementation, it was basically a toss-up between LGAML and RSA. And there's a few things that I think kind of pointed us towards not going with LGAML. So one of the simple ones was that the actual library itself didn't recommend it. It's a good starting point. We also did some more further research, and it was saying something like the signature was twice as long or something like that, or the message text was twice as long. I can't remember the exact details.
Also, the fact that you have to calculate the key in advance, or the size of the key in advance.
That's it. Yeah, it does. Is it something weird, like you have to create a new key or something, or I can't remember the exact. There's something about that where the key, you can't just use the same thing all the time. And also there was a thing about when we tested it very briefly with the recommended key length, which was 2048. It was basically infeasible to compute on a desktop computer, so it took about 30 seconds to generate the key. Now it may be that we could have used a smaller key bit size, but then that would require, see here, this talks about using this. This took far too long. So that was the main reasons. And then we went with RSA because it's pretty standard. It's easy to understand, and it was pretty fast. So I think that's sufficient. What else? Hashing. I think we just went with MD5 256 at the moment, did we? I think we did.
Yeah, I think we used MD5.
That was one of those things where it was about just as secure enough.
No, actually, I think we use SHA.
Sorry, yeah, I meant that. I just said the wrong thing. Yeah, we definitely didn't do MD5. That's shite.
Yeah.
You're right. Yeah, we did. Yeah, so we basically went for the kind of vanilla thing that's secure-ish, pretty secure, and it's pretty fast. We didn't go for something that's very fast and not secure, which would be like MD5. And we didn't go for something that would be very secure and not fast, like with a larger key size, like 512 or something. So I think that's it. I mean, it's a hash, so it's not terribly slow to compute anyway. It's probably the slowest part of this is probably the signature stuff with the keys. But we needed the asymmetric key to do the signature stuff, because that wouldn't. You can't do signatures with symmetric keys, so that was the reason we went with RSA. We didn't encrypt the actual message contents, like the entire body, because one option is to do it with something like AES or something. But we thought, based on this as being an Internet of Things device and stuff in the signature, we're kind of protecting the block from being tampered with, but we're not protecting the block from being viewed in flight. And that was just based on the kind of time constraints, resource constraints of the system, potentially having to add extra encryption, and kind of a lack of requirements that the data needed to be, secured in flight, basically.
Yeah, write it as an advantage rather than, we didn't have time for this, but we actually no, it's actually better because then it runs faster. So
Yeah, it does. It definitely runs faster. Yeah. And if it's something like, if there's no personal information in our pretend system, like if it's just CO2 data, then there's not necessarily a need to encrypt it anyway. We're not submitting like personalized blood pressure ratings or anything. So yeah, I think that's fine. Talked about that. Basically we just need to talk so much. So some of this stuff will probably go into the report as well. So I don't know how much crossover there is, but we might need to mention both of them. This stuff is currently in flight. So I think, unless anyone's got any questions about this document, probably go and have a look at the PDF and talk about what currently happens.
We should also talk about the how we use the virtual environment and classes and everything.
Yeah, it's a good idea. Yeah. So
because
I'm hoping everyone's pulled down the code, but I've got a README which is actually might be quite useful actually. So we use Python 3 for. My VM just crashed now. We used Python just crashed. We use Python 3, so that's another design choice because Python 2 is end of life. But yeah, I'll talk about the virtual environment. Well, yeah, so there's two things actually. There's the VM itself. So we actually used a VM maybe apart from me, but I'm pretty sure everyone used Costin's VM. So we actually standardized the development environment, which is, it's good to talk about. And we had issues with, it's been a long time, but remember we had issues with getting Mininet set up because the default VM didn't work. It's a pain in the ass. So we basically created our own, Ubuntu or Lubuntu, whatever it was, derived development environment. And as part of that, we used Wireshark for testing. You all right for notes, Costin, or shall I slow down a bit?
Yeah, no, it's fine. I'm just typing away.
Cool. So the next thing I think we're talking about is we use a standardized version of Python, and we used a standardized version of Mininet. So we all used the same version. I think it's 2.1.3 or 3.1 or something. I can't remember the exact. But we basically, because we had the same VMs, we were all using the same one, and that was important because 2.2 I think doesn't support Python 3 code. The next thing we did is we standardized the actual Python environments. We used a virtual environment, so every Python code that was running, it was running identically on everyone's system. So we had, you might have seen this file with all of the standardized dependencies. So by doing these steps, then it meant that everyone was running the same libraries and stuff. And that basically reduced the chance for, it works on my machine but not on yours kind of scenario. Yeah, there's a whole bunch of stuff here. We standardized the code formatting, ran automated tests, I don't know if you've seen where we did code coverage. That's the kind of the technology choices.
Alex, 1 second. How's the actual thing called, the black thing? How would you actually search for it?
Black code formatter.
Oh, thanks. Fair enough. Easy enough.
Do I have a link in there? I can't actually remember.
No, I don't think you have a link in there.
Oh, it's the name. Yeah. Oh, I do. Yeah.
Oh, I'm just blind. Sorry. Ignore.
Yeah. It's my thing's lagging a bit. Yeah. So, and the reason it's kind of twofold. First of all, obviously, it's nice to have formatted code, but one of the really good reasons is that it makes the diffs a lot easier because you're not having to look at white space changes and brackets and the wrong lines and stuff like that. So if you use a standardized code formatter, it means that it's a lot easier to compare code.
Also, we haven't done this yet, but we need to mention it because we're gonna do it in the end. We added lots of comments to make sure this project is viable to be refreshed and reused further on. So
yeah, and we kind of split stuff into modules, and I mean theoretically this thing could be deployed into like PyPy or something at the moment. It's a local development build, but this could be deployed as a real build if we just published it. So it's not just a few janky scripts holding together. I think that's probably it for kind of dev setup and dependencies and stuff like that.
just 1 second. What about PyTesting? Because I didn't have time to write about that. What did you say about PyTesting?
So we used PyTest for unit tests. So like we can probably do this when we do the demo, but a lot of the key functionality like the cryptography, block configuration, serialization from JSON, etc., is unit tested. So because it's faster than obviously running the full integration manual suite thing. And PyTest is basically almost the de facto Python testing framework because it can do everything that unit test can do, which is another framework which comes with Python, plus it can do extra stuff such as parameterized tests and stuff like that. So, and it's a lot less code to write. You don't have to write a class and things like that. You just write test and it just does it. And yeah, we have the code coverage, so that's why we did that. It has actually worked. I've actually found a few times where I pushed stuff and forgot about it, and then realized I've actually broken something. So it's definitely
all hail the test.
Yeah. The other thing, what else? Since we're going through all this stuff, then talk about GitHub. So we used GitHub because, well, first of all, it sounds basic. We used Git because we didn't want to just copy files in teams. That would have become a nightmare very quickly. And we used GitHub Actions for the continuous integration pipeline. So every commit, we basically run a test and checked for code formatting, basically. Okay, I think we're ready to talk about the solution design and the networking and stuff like that. I'll open it up. So I'm hoping everyone here has seen these diagrams. There's two main ones. So there's a high level one, which is, I think, this, which is fairly close to reality now, apart from this.
Oh yeah, we should mention that we tried to use DHCP, but yeah.
Yeah, it was deprioritized basically is the answer. We didn't invest time in it. But the solution will work with dynamic. The solution does work with other dynamic stuff, so it's not miles away from that. I'll go through the PDF because I think, in case people aren't aware, what the kind of solution does at the moment and what it's hopefully going to do and what it's probably not going to do. So on the left here we have the nodes, and on the right we have the miners now. And this is the switch. So under the basic implementation, there's meant to be at least 5 miners and 5 hosts, 1 miner. We designed the solution to be flexible, although there's some issues at the moment. So the original idea was that every node, so miner or host, when they connected to the network, would then talk to the DHCP server and be given a dynamic IP address, so they didn't have to have a statically defined IP address. And the idea behind this was that if we have more nodes join the server dynamically, it's a bit more flexible in a real life scenario where you'd be potentially hot swapping different devices into the network, and it'd be more scalable because you wouldn't have to manually define the IPs and check it's not been allocated and stuff like that. We didn't go with this in the end just because of time, but as part of that, we also did extend this. So rather than having every single host and miner be given a static list of IPs that represents all its neighbors, in this case, every host needs to know every miner so that it can potentially choose who it needs to send the block to, and every miner needs to know every host so they can send the validated block plus every miner for the same reason. This is all worked out dynamically, so we use UDP for this because it can be broadcast to every device, and it's fast, and it didn't need to be reliable in this case because we're doing it basically every interval. So that was the reason for UDP, and this is basically every device sends out a heartbeat message every, how many seconds it is, 5-10 seconds, telling every other device in the network basically it's there, and it contains stuff like its public key and IP address and stuff like that, so that as soon as a device joins the network, it can basically inform everyone that it's there. And basically once this runs for about 5-10 seconds on startup, every node knows about the relevant nodes they need to know about. This is just more of the same. So the main thing for that design decision was the flexibility, the scalability, and also we use UTP because of the speed and because of the broadcast capability. We wouldn't be able to, by definition, send a broadcast to everyone not knowing them. With TCP. So that's why we had to use UDP for that. That's the same thing. So basically, yeah, when the devices are initialized, and it might be worth me just showing everyone what, I know Costin knows what the code does, but just showing everyone what this means. They all get these set up. and again, this is because when the miner creates when the host creates a block, it needs to pick a random miner that fits the trust rating. So it needs to know the IP address of that miner. That's basically it. And the same for when the miner sends out the blocks, it needs to know where to send them to. So again, it needs the IP address. That's the block thing. So we use TCP, so that's the difference. We use TCP for the actual block transmission because we wanted it to be reliable, and that's why we needed the actual IP addresses. So it's point to point with a handshake, and also we've got retry behavior now, don't we? So that's an extra level of implementation. So yeah, basically generate new block, goes to miner, miner then validates block, miner sends block to everyone. That's then the block that gets synced across all devices. There's currently an issue, as I said, with the ordering of multiple miners. We think it might be able to be resolved by a queue. It's on the kind of medium priority. I think the higher priority for me anyway is making sure all the kind of signing and stuff works. I've just been working through that, but we'll get to outstanding work in a bit. It's more about the design. And then again, new block gets generated, goes to a different miner this time, goes back, gets added to the chain. So hopefully this stuff should be kind of similar to what we read in the paper. It's really just we've got the dynamic differentiating factor of having those dynamic heartbeats that build up these lists, because it means if we have, this is the cool part, if we have a new host added to the network, the host will start running the initialization code and it will receive heartbeats from everybody because they're going out periodically, and it will send heartbeats. It will then dynamically, without any configuration, work out everyone in the network, and then it will be able to start joining the network. And the only thing that we've not got is that it doesn't get a dynamic IP address, which would be the kind of the last part of the puzzle. But this would still work with a fixed IP, provided we gave it a unique one. So that's basically the process of syncing up the heartbeats. If anyone's worked with kind of like sort of microservice architecture and stuff before, this is kind of similar to sort of network discovery and stuff that's used to make sure all the containers know where they are. It's a similar idea. That's basically just receiving the new block. And another important thing here is we receive, when we plug in late, as it were, we only receive the current blocks from the time that we've been connected. We don't try and kind of backdate it with previous blocks. This was partly a design decision because there's not necessarily needed a history for IoT, but also for a time constraint. It would be achievable to get like all of the previous blocks, but we would have to basically connect to different nodes and then try and download them.
Also, we can link it to the fact that it would add network strain, so it's actually a plus.
Exactly, yeah. And it's not like something like blockchain where it makes sense to have the previous transaction history to download the entire blockchain. There's less of a clear use case why you need to have the history going backwards from the time, because the implication is that you don't care about the bit that you've not connected to before. Yep. So the nice thing about the heartbeat system, as I said, is that it works a bit like a kind of a timeout thing. So if a device turns off, it will stop sending the heartbeat, and we've got a mechanism so that every device after it stops receiving the heartbeat from a particular device for a particular period of time will realize that it's not responding, and it will then remove it from its list. So this kind of means that you don't waste time sending messages to someone who doesn't exist, which could is basically wasted network communication. And also, more importantly, for the hosts, you're not going to try and send blocks to a miner that's not there, because that would actually result in lost blocks. Yeah, so that's basically that gets synced across. This is the current block validation stuff. So think there's still a bit of, this is still not fully fleshed out because it looks like maybe the description and the requirements are slightly different. This currently happens, discarding an invalid block, but the next part about how we actually handle corrupt minors is a bit more tricky. And I think this slide, we need to maybe just revisit this. But the gist of it is that you somehow need to tell the corrupt minor that it's corrupt and punish it, and then make sure that it doesn't contain the block that it added. That's the idea, is that the corrupt block is not added to the blockchain. Again, this is the stuff under the proof of authentication stuff that we talked about in the first paper. And the trust values are actually, or the trust ratings are actually sent in the heartbeat. So every kind of 5 seconds or whatever, every device, every miner is sending out its trust rating. So this means that when we go back to sending the block, each host can decide, it knows, it has an up-to-date picture basically of all of the trust ratings, then it can use that to pick the right ones. So I think there's 2 points, isn't it? We've got some decisions that we've made about design, and we probably need to also show something in the presentation, probably similar to that. Some kind of nice diagrams similar to this. We don't need some of these steps. I think we don't need the DHCP steps. And then we probably need a variation of this. This is not miles away from being ready, but it's not quite that clean.
Also, again, here the ACB server can be omitted.
Yeah. Yeah. And we also probably need screenshots or something of the actual thing running.
Well, we can actually add those screenshots like Tuesday evening after the presentation is done. We can just shoehorn them in. Anyways, it's gonna be a 15-minute presentation, so it's a lot to talk about. It's really a lot.
Yeah, I mean, how long have I been talking there? That was even just going through that took quite a long time, so it's not.
So we're gonna have to see and condense, yeah.
Yeah.
What else? Oh, and we also have to talk about our structure a bit. Just the minute PDF thing, where we tell about
stuff like
that we parallelized all the things and we have different threads running different things.
Yeah,
that's also important.
A lot of it's non-blocking. Yeah, so for example, you can be sending out the heartbeats while simultaneously receiving other heartbeats, whilst simultaneously creating blocks, while simultaneously checking for heartbeats that have expired, whilst simultaneously receiving new blocks. And we just use locks to basically lock down the shared variables, but only the ones that need to be locked and only for the minimum amount of time. So the throughput is fairly high. And that's, again, another thing that's important for scalability, because if we had just one thread blocking, you can't, it doesn't even work if you have one thread, because you can't, for example, send out a block and then wait for another block inevitably, because that means you can't create a new block until you've received a block. So there needs to be some parallelism. Yeah, the keys are all distributed again through the heartbeat. So there's basically no central authority that, apart from the code that starts the application, but that's obviously an emulator. In real life, you would just turn on the applications in each device, and then apart from the IP thing, everything else is decentralized. They automatically tell everyone they're there. They automatically send all the important information and then just start working. I think that's one of the main strengths of our solution. I think what I'll do maybe is I'll just do a very quick demo of what we've currently got, just to give some context to what I've been talking about, because I realize I've just been kind of speaking for 20 minutes. This is more just so that the stuff that we've talked about in the slides can make sense. So if I just do We also use standardized logging as well. It might be worth mentioning that at some point. It meant debugging was a lot easier, and we could change the logging for individual parts of the application, and control where they went to. They all went to for individual files for each device, which also makes things easy to debug. If you just went with printing to standard out, this would be an absolute clusterfuck. So we can see here. Costin, this is a sneak peek of what I've been working on, by the way. But yeah, we can see here that individual devices have individual logs, which is actually more realistic, because in the real world, they would be separate Raspberry Pis or whatever, and they would have their own output. They wouldn't be just logging to a centralized server.
Two things I want to say. One, nice. Second of all, holy shit, that signature is long.
Yeah. Well, that's what 2048, whatever it's going to be, is going to be. It's just yeah. I had to base 64 encode it to send it. But you'll see that it's not printing out the blockchain. This is kind of going off topic a bit, but previously we had issues where the blockchain was getting printed out in the log, so the log was getting exponentially larger. Fixed that.
Yeah, good thing. And now that we know it's working, they're adding it, we don't need to see that.
Yeah, exactly. And it goes into this directory. But so basically what happens is I'll just show you the logs. So in this scenario, this is like the basic implementation with one miner. So we can see here that it connects, it starts different threads. So this is saying I'm starting the validate block thread. I'm just listening for new blocks to come in. And then also this is listening for blocks that are being validated by other miners. And then it dynamically works out all of the hosts in the system. This is at info level, so it's quite high level, but what happens is it sends lots of UDP messages. So this is scalable, because in 5 seconds it's worked out all the hosts, and we can change how fast the messages get sent. So I've tested this with 25 hosts and it works fine. Multiple hosts is not an issue. Miners are an issue at the moment, but that's another thing. And then what basically happens is that it will receive a block. So if we show them the host code, we can see that similarly, it listens for heartbeats. The host waits for a period of time, so that and everything is also config driven as well. That's maybe another thing we can talk about just to make it more flexible. It's all config driven. But basically, yeah, the hosts wait for a period of time until they've received, or basically they give the system enough chance to receive all of the miners, and then they pick a random miner. In this case, there's only one miner, and then they send the block. The block format needs to be finalized, but that's what it looks like. And then they periodically send blocks to the miners, and then the miners periodically receive blocks. That's pretty much it. I can't remember if I was changing this at the moment when I was. Yeah, so I was testing something at the moment before I went on this call, so with the wrong signatures, so it shouldn't actually create any blocks, which is correct. Main thing is that there's multiple things happening in the background. And this might be when we talk about the report, but because there's basically a single process that's running in sudo to run the miner, to run to run the mininet code, and then that starts a process for every host, and every host starts a thread. There's a lot of stuff happening. So actually, even just shutting down the system is actually quite complicated. And what happens here is that we basically tell it to shut down, and then every thread will basically recognize that it's about to get shut down, and then it will stop creating new blocks, and then wait for the existing blocks to get processed. Because we had an issue where CSC is waiting here to cool down, and likewise, it's stopping new blocks are being created, and this basically synchronizes all the blocks so that you don't lose any blocks that are currently, being processed but have not reached all miners yet on all hosts. Yeah, so I'll do one more time just to show some blocks coming out. That's the design decisions about the threads. So the threads do make it more complicated, but as I said, they make it more flexible. I don't think we need to go into massive detail for the presentation, but it's more just to give everyone a background about how the stuff that we've been talking about actually works with these things. Each of these things here is a thread, and each of these is color coded. So this corresponds to this. So they send from the host and it gets listened to by the miner. They send from the miner and it gets listened to by the host and other miners, etc. And this is a kind of a script, a main Python process. There's a process running for the host, for the mininet topology, and for the miner, and then each of these processes has its own threads. And there's n number of hosts and n number of miners because there's obviously multiple. Yeah. So now we can see the validation is turned on. So it is pushing new blocks, and the blocks just get written at the moment to JSON. So you can see there's blocks in here. Block format to be confirmed, but we needed a way to verify that the blocks were actually correct and in order. So that's why I think we've gone with this. We could have used a database or something, but again, time. And also, it's not strictly necessary to have it. I mean, you could have like an SQLite database or something.
Alex, just a quick thing. Have you used my code or have you gone back to using JSON?
I used your code, but I had to serialize it to go into JSON.
Oh. Yeah, fair enough. Nice.
Yeah, it uses the linked list thing.
Okay.
Yeah, we needed to wait to check it was working. Basically, that was what I did this morning.
Yeah.
So I'll just finish this. I'll just run the verify thing, and then I think that'll be enough for the demo.
Also we need to mention that we used a serializer, and you wrote in a script to verify that the actual thing.
Oh yeah. I mean, we used. It seems obvious. There's another design decision to use JSON. We could have used like a custom format or XML or something, but for the actual the messages that get sent over the network, we use JSON, mainly because it's flexible and it's human readable. You can represent structured data like Python dictionaries pretty easily, and it uses less space than XML, and it's standardized. So it works with a lot of tools, and it's quite nice to read if you just print it out, which is what we've done here. So you can see here the verified code now checks they're all. I mean, there's more stuff we need to do. I think once we get the actual block format verified, you actually probably need to parse this and check that every signature refers to, or every hash refers to every previous hash. But that's not what we'll talk about for this discussion. The main thing is that the basic implementation is working at the moment. We're kind of battling through this at the moment, and because I'm working on that, and I think Carsten's helping with that, we need other people in the group to work on the presentation as a priority, and then also on the report. Obviously, after the code demo on Wednesday evening, so Wednesday afternoon, we can't change the code. So at that point, everyone will be working on the report. But what we can't do is just wait until then. And what we certainly can't do is wait until Tuesday night to try and think about the presentation. So I know not everyone's in this meeting, but we really need to kind of pull the finger out. And
also, I know it's 8 p.m. in your guys' country right now, but I'm not expecting you to work a lot tonight. But please, 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 tomorrow morning start working on the presentation. It's really, really vital. Me and Alex do not have time to handle the presentation. You can ask questions and we can explain what we did and everything, but we really don't have time to actually start writing and actually start doing the diagrams again. That's why we have uploaded the rough diagrams and asked you guys to remake them a bit nicer. So yeah, that's how it works.
Okay, I will write down. Yeah, I will write down the points you mentioned. And,
yeah, I wrote down everything. So don't worry about that. I did. I created a file here that has everything we've talked about and what you have to talk about. You just have to make it into a presentation and make it look nice.
Yeah.
So
share that to Teams. Yeah.
Yeah, I'll share that. I'll share that to Teams in a second. So yeah.
Do you have any more information about the presentation? It's obvious. I guess it's going to be on Zoom, is it? Like a shared screen or something?
Basically, it's going to be on Zoom,
Yeah.
share screen, and we're going to first do we're going to have 15 minutes to do our presentation where we actually go. We only have to go through the PPT. We're going to talk about what we did in the PPT. And then we're going to be pulled separately without the other teams. And we're going to have the demonstration with the demonstrator itself where we're going to have to run the code. So that's all I know for the presentation.
To see if there's any more.
Who will be the speaker?
Me and Alex can both present. I don't think there's an issue with that. We can both talk if you guys don't want. You both know the system pretty well.
Don't worry about that. It's more just about time. What we probably want to do though, guys, is have like kind of a rough, like a walkthrough with the presentation, kind of mid. I have to think about time zones, but we definitely we don't want to just go in cold. So I think the deadline. Let's just check this for when this actually is due. I think it is 8 a.m. Wednesday.
Yeah, so it's quite late for you guys. So what about 12 p.m. on Tuesday, 12 p.m. UK time, to have the presentation done?
And that gives us time if we need to we can continue to work on it. Because let's have a look at it. Okay, that's actually longer than what. Bit of conflicting information there.
Yeah, so 20 minute discussions. The thing is, they said, there might be different, but yeah, either way, we're gonna see it when we get. If it's 25 minutes, it's 25 minutes. If it's not, it's not. We don't have to occupy the whole time. We can ask, as me and Alex both know the system quite well, we can handle questions, so that's no problem.
Do we have? I think I just looked at that page.
Or even better, we can send a message and ask really how long the presentation will actually be. If that's even better for you guys, to make sure.
Yeah, let's just do that as well.
Yeah, I'll
doing that.
And I'll update you guys.
That's the report. That's not yet for this. Well, this is in the case this has been updated since I've downloaded it. Let's just check again.
Don't think it has.
No, I mean there was an email, something about saying there's some queries, but I didn't notice any additional stuff in here.
Yep. That's probably just Paul saying that, guys, you haven't read the frequently asked questions. Go read that before asking things.
Yes, yeah, definitely read it. Others wouldn't be asking the questions. There's like a whole paragraph on this and nothing on the actual like requirement of the presentation. So 8:30, right? That's early. So that's for all intents and purposes. Apart from, well, I guess theoretically we could.
No, Tuesday evening is a deadline. I want it submitted on Tuesday evening.
Yeah, it needs to be Tuesday night basically. Which means we need to do a. Okay. I'm going to put a meeting in then for Tuesday, 12 o'clock then, if that's all right.
Yep.
And basically, there's a little bit of time from Tuesday to Tuesday night, but for I'd rather not have to spend time doing presentation on that because A, the code might need to be fixed, and B, there's enough time to get a rough cut. You can ask questions before that. demos, yeah, fine. That's the actual report, so the stuff that we've talked about today can probably go into the report as well. Do I have any more notes on this? This is not that. That's right. 20. Okay, so this is from when I was listening to what Paul was saying. So he said 25 minutes at the time. Solution architecture, design, decision, rationalization, what works, what does not. So that's what we've talked about this meeting. Can nominate any subset of the group to talk. So not everyone has to talk. So let's just go with me and Cost in case unless anyone's got any objections to that. Yeah.
6 times 5, 30 minutes. Yeah, it's about. So yeah, it's going to be 25 minutes. Yeah.
All right. So we can afford to go into some detail.
Yep.
And like we can probably talk. It's more just a question of having something on the screen. Yep. Okay. Right. Stop sharing my screen. I think that's it. So does everyone know what the ask is? Priority of presentation. I'll put a message in the chat as well for people who are not here, but it's not great that you know, we're kind of in the last few. We're down to hours basically rather than days at this point now. So we need to just be smart about what we prioritize and what we don't. But yeah, I'll put a meeting in for 12 on Tuesday, and hopefully, you know, you two plus everyone, the other two that I think who are not here, yep, can pull something together, and we can go over it, and basically do a demo, talk through it, and that should give us a little bit of time.
Also, please let us know that you're actually working on stuff, and because I don't want to wake up Tuesday evening with nothing working on PPT, no work, nothing done. Just let us know that, okay, I'm actually working on this stuff. I will be. Just split your tasks, and I'm as Alex is going to post this notes with meeting of this meeting, and I'm going to post the actual things that have to be added to the PPT. Just in that comment, just reply what you're working what you're working with and what you're adding, so that not all of you work on the same thing. Okay.
And even if it's just making the diagram or something, like that's still useful. So I think this meeting is recorded, so people who have not attended can view this if they need to.
Yeah, I will watch it many times.
Yeah. Okay.
We
So
will take care of this task. So
okay.
take it easy.
Okay. Okay. Yep. Okay. I'll put the meeting in to go over the presentation on 12 o'clock on Tuesday, and I'll send out a message in the group to just make sure everyone's on the same page. Then yeah, we upload the notes from today. That'll be good. Cool. Okay. Any other questions before we close this?
No.
Okay then.
Okay. Cool.
So okay, please guys, work on this. We really need you this time. Okay. Yeah.
Okay. Yeah. Bye.
Thanks,
Bye.
guys.
Ngày mới thuê mà.
Mới thuê.
我们那个演讲是某一个人演讲，还是我们一个人演讲一部分的？
一个人演讲，咱们要写好 PPT。
那有需要我做的吗？
有啊，咱们要做 PPT 啊！你没看人家说的，你们啥都不提交，这个我们没有时间。希望你们能，咱们
做
得做
PPT 对吧？
对，要写报告做 PPT，现在只用做 PPT。
啊，你
就把
有什么需要我做的，你直接告诉我，我听不懂他们说什么。
好，我把那任务分分，
嗯，
咱们跟那个女同学加不加那个 Zack？
加啊，他听得懂中文呐、我们那个群里不是有4个人吗？
嗯，行，那咱四个做做。
嗯
好，那我去看看。
嗯，你有什么东西跟我说一下，我他妈的。
周二12点就要做好提交。
啊，然后周3演讲是吧？
对他们演讲，他们管 handle 的问题。
你那个 project 是明天吗？
啥 project？有
就
个新课
是最后一个那个什么之前
8499。
选题的那个，8499，
嗯，对，明天。
明天早上是吧？
对，是的。
好，
嗯，
那你有什么需要我做的，你直接发给我，我就开始搞。
好。
嗯，
行，那挂了。
好，拜拜。